this is chapter 4.4a, the properties of rational functions. Let's get started with number 16. You need to know that the domain for the rational functions are always going to be all real numbers except certain values. That certain value is going to be the real zero of the denominator. So you want to set that 3 plus x equals to 0, and then go ahead and solve for x. So x is going to equal to negative 3. So your domain is going to be all real numbers except x equals to negative 3. So number 22, the denominator, x to the fourth power minus 1, you want to set that equal to 0. And then I can start factoring.
As x squared minus 1 times x squared plus 1 equals to 0. I can factor a little more on the x squared minus 1, so I can rewrite that plus 1, x minus 1 times x squared plus 1 equals to 0.
If you set these two equal to 0, you're going to find out that x is equal to positive and negative 1.
This is going to be your imaginary. Okay, so you can just ignore that. That's not going to be part of the domain. So
Your domain is going to be all real numbers except x equals to positive and negative 1. So here, if you set the denominator equals to 0, x to the fourth power plus 1 equals to 0. And this is actually going to give you imaginary. Your domain is going to be all real numbers, and there's no exceptions. Number 26. So for here, you want to set the denominator equal to 0.
okay, so 3 times x squared plus 4x plus 4 equal to 0. And then you're going to factor out the x squared plus 4x plus 4. So you're going to factor 2x plus 2 times x plus 2. That equals to 0. So
Where x is actually equal to negative 2. It happens 2 times. But we can just write it once. So your domain is going to be all real numbers except x equals to negative 2. Let's look at number 28. So I'm going to start with horizontal asymptote. This is where y equals to 0. And the vertical asymptote is right here. This is when x equals to negative 1. Okay, so there is no oblique asymptote. And the domain is going to be all real numbers. So just put all real except x equals to where the vertical asymptote is negative 1. The range is going to be anything above where the horizontal asymptote is. So you're going to put y is greater than 0. There's only going to be one intercept, which is the y-intercept. Okay, so that's going to be 0, 2. Let's look at number 30. So I'm going to start with the horizontal asymptote. There's obviously none. I don't see any. So vertical asymptote is right here. This is where x is equal to 0. And the oblique is going to be this slanted line right here. And the equation is going to be y equals to negative x. Now let's go ahead and look at the domain. So it's going to be all real numbers. So let's just put all real except where the vertical asymptote is. So x equals to 0. The range is going to be a little tricky. So look at this curve. The range is going to be everything above where y equals to positive 2. So you're going to put range is y is greater than or equal to positive 2. For this part of the range is going to be where y equals to negative 2. So you're going to put y is less than or equal to negative 2. Okay, there's no intercepts, so you're going to put none. All right, so number 32. We're going to start with the horizontal asymptote. So it's going to be right here. This is where y is equal to 0. And the vertical asymptotes, we got 2 of them. One of them is negative 1. Another one is going to be positive 1. So you're going to put x is equal to plus minus 1. Okay. I don't see obliques, so you're just going to put none. Okay, so for the domain, you're going to put all real. X is not equal to plus minus 1. For the range, it looks like because of this middle part, you can check it and see that it obviously covered the whole entire range. So the range is going to be all real numbers. So the only intercept you see is right here at the origin. Okay, so it's actually going to be x and y intercept, and then it's going to be at the point 0, comma 0. All right, let's check on number 46. So we have to find the asymptotes. So start with the VA. The VA is the easiest. All you need to do is go ahead and set the denominator equals to 0. So you're going to say x minus 6 equals to 0. And the add 6 on both sides. X is going to equal to positive 6. So your vertical asymptote is where x equals to positive 6. Let's check out the HA. So HA is going to be, you set the function equals to y. So you're going to say y equals to, you're just going to compare the highest degree of numerator and denominator and say that is 3x over x. Okay, so y is actually going to equal to 3. So your horizontal asymptote is where y equals to 3. Since you have a horizontal asymptote, that means that you don't have oblique. So it's going to be none. Okay, so let's check out the next one. For number 48, so we're going to start with the VA.
So set the x squared minus 5x minus 14 equals to 0, and then factor it, so you got x minus 7 times x plus 2 equals to 0.
So x is going to equal to 7, x is going to equal to negative 2. So your vertical asymptotes are going to be where x equals to 7 and negative 2. So if you look at the horizontal asymptote, set the function equals to y, and then just go ahead and compare the highest degree of the numerator to the denominator. And it looks like you're not going to have the horizontal asymptote because your numerator has a higher degree than the denominator, so makes it none. Okay, so we have to figure out if there is an oblique asymptote. The long division
X, and then you have x cubed minus 5x squared minus 14x. Subtract it, you get positive 5x squared plus 14x, and then bring down the 1 plus 1. Okay, so you put plus 5, and you're going to get 5x squared minus 25x minus 70.
you got to see that remainder equals to 39x plus 71. You don't have to even worry about the remainder. This is going to be your oblique asymptote. So number 56 is going to be slightly tricky for the vertical asymptote. The numerator, so we're going to write that as x squared minus 4 times x squared plus 4. On the bottom, I'm going to factor it as factor out the x. So I'm going to get x times x minus 2. This can be factored a little more to x minus 2, x plus 2. Okay, go ahead and cancel the x minus 2. So you can simplify the entire fraction to x squared plus 4, x plus 2 over x. So your vertical asymptote is just going to be 0. I'm going to erase everything. The horizontal asymptote is going to be, you said this equal to y, right? So y, you're going to compare the highest degree of numerator and denominator. It looks like the numerator is higher, so that's going to be none for the horizontal asymptote. So this is for the HA. Okay, so for the oblique, if I have 2 degrees higher, that means that I'm not going to have oblique asymptote. All right, that's it for this lesson. Take care.